Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSE, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we learned about how to represent trees. Now, in this session, we are going to learn about binary tree. Overview of the presentation. In this presentation, we see definition of binary tree and how to find max and minimum nodes of binary tree and how to find minimum height of a binary tree if they are giving number of nodes, and finally we see the different types of binary trees with some examples. Outcome of this lecture: at the end of this lecture you all are understand properties of different binary trees we have in data structures. So, definition of binary tree. So, binary tree are the data structures in which each node has at most two children called as the left and right children. So, binary tree. So, binary means two. Okay. So, tree have at most two children, then we call that tree as a binary tree. Now, consider this. So, this is the node we have. Is it binary tree or not? How we know? The definition. What is the definition? At most two children. Okay, here the number of children are 0. It satisfies this condition, so it is a binary tree. Now, this is the tree. Is it binary tree? Yes. The number of children are 1. It satisfies the condition. What is the condition? At most two children. So this is the number of children are 1. So, it is also a binary tree. Now, the number of children are 2. So, it is also a binary tree. So, consider this. The number of children are 3 now. Is it binary tree? No, it is not a binary tree. Why? The definition of binary tree is each node has at most two children. Okay, now, so consider this tree. So, this is the node have two children. So, this node have two children. So, this node have two children. So, it is a binary tree. So, for example, so this is also a binary tree. Now, so this node have two children. So, this node have 1, this node have 0, this node have 0. All the nodes satisfies the condition at most two children. So, we say that so this tree is a binary tree. So, binary tree is a family of data structures: binary search tree, heap tree, AVL tree, red black trees. I hope you all are understand what is binary tree. So, binary tree is a data structure in which each node has at most two children. So, now we see how to find the maximum number of nodes possible for a binary tree. So, this depends on height of the tree. So, what is the height of the tree? So, for example, this is the tree we have. Okay. Now, so what is the height of the tree? The height of the tree is 2 now. At root, the height equals to 0. So, next level increment the height by 1. So, it is 1. So, this is the 2. So, height of the tree is 2 now. Okay. Now, the maximum number of nodes possible for a binary tree depends on the height of the tree. The relationship between the maximum number of nodes n and the height of the tree h can be expressed as n equals to 2 power h plus 1 minus 1. Okay. Here consider this. So, this is the tree. Now, what is the height? H equals to 0. The number of nodes are 1 here. So, consider this tree. What is the height? 1. Number of nodes are 3. Consider another example. So, this is the tree. So, what is the height? Height equals to 2. N equals to 1, 2, 3, 4, 5, 6, 7. So, consider this. the maximum number. The height equals to 3. The maximum number of nodes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. N equals to 15. Okay. So, now we see formula to find the maximum number of nodes in a binary tree, that is n equals to 2 power h plus 1 minus 1. Now, consider this first example. Now, what is the h? 0. So, substitute here. So, 2 power 0 plus 1 is 1 minus 1. So, 2 power 1 is 2 minus 1 equals to 1. So, the number of nodes n equals to 1 here in this case. Now, consider h equals to 1. So, h equals to 1 plus 1, 2, 2 power 2, 4, 4 minus 1, 3. So, number of nodes are 3. So, consider h equals to 2, h power 2 plus 1, h power 3. So, 2 power 3 is 8, 8 minus 1, 7. So, this is the 7. If the height h equals to 3, then so 2 power 3 plus 1, that is 4, 2 power 4 minus 1, 2 power 4 is 16, 16 minus 1, 15. Okay. Now, what is the formula to find the maximum number of nodes possible in a binary tree? That is n equals to 2 power h plus 1 minus 1. So, these are the examples. Okay. So, now we see, so how to find minimum number of nodes that is possible in a binary tree with height h. That is the minimum node number that is possible at this height h. It comes as equals to h plus 1. Here we are calculating minimum number. For example, this is the minimum number of nodes. So, possible at height equals to 0. Now, consider height 1. Now, minimum means only one node. Consider height 2. Minimum number means only one node. So, h equals to 3. Minimum number is only one node. Here the formula to find minimum node is h plus 1. If the h equals to 3, the number of nodes are 4. If h equals to 2, the number of nodes are 3. If h equals to 1, the number of nodes are 2. If h equals to 0, the number of nodes are 1. So, the formula to find the minimum number of nodes in a binary tree is h plus 1. If 0, the nodes are 1. If the height is 1, then nodes are 2. If height is 2, then minimum number of nodes are 3. Okay. So, now we see how to find minimum height of binary tree. So, already we know that the maximum number of nodes present in a binary tree is n equals to 2 power h plus 1 minus 1. Okay. So, now add 1 here. Now, it becomes as n plus 1 equals to 2 power h plus 1. Now, apply logarithmic. Now, it becomes as log 2 n plus 1 equals to h plus 1. Now, here we are going to find the minimum height. So, h equals to log 2 n plus 1, here plus 1, it becomes as minus 1. So, suppose we have a binary tree with 15 nodes. So, find minimum height of a binary tree. Now, substitute here h equals to log 2, what is the n here? 15. 15 plus 1 minus 1. Now, log 2, so 15 plus 1, 16 minus 1. So, log 2 of 16 is 4. So, 4 minus 1, 3. So, the minimum height here is 3 now. How to find maximum nodes so present in the binary tree? That is n equals to 2 power h plus 1 minus 1. So, how to find minimum number? N equals to h plus 1. How to find? So, minimum height h equals to log 2 of n plus 1 minus 1. You remember these three formulas. Okay. Now, we see so types of binary trees. We have different types of binary tree. So, what is a binary tree? So, binary tree, all the nodes have at most 2 children, that we call as a binary tree. In these binary trees, we have different types of binary tree. So, one is full binary tree, second one is perfect binary tree, third one complete binary tree, fourth one balanced binary tree, and fifth one degenerate tree. Okay. So, let us see one by one. So, now we see definition of full binary tree. A full binary tree is a binary tree in which every node contains 0 or 2 children, but not 1. So, consider this example. Let us consider this example. Is it binary tree or not? Yes, it is binary tree. So, how we know that? All the nodes present in the tree have at most 2 children. At most 2 children means there may be a 0 children or 1 children or 2 children. Now, so for this node the number of children are 2. So, for this node 2 children, here 1, here 1, 0, 0, 0. It satisfies the properties of binary tree, but it is not a full binary tree. Why? The property of full binary tree is every node contains 0 or 2 children. So, consider here it have 1 children. So, if this tree is like this, then the number of children are 2 or 0. Now, so this tree we called as full binary tree. So, perfect binary tree. A perfect binary tree is a binary tree in which all non-leaf nodes have 2 children and they are at same depth. In our previous example, if you observe here, so these are the leaf nodes not at the same level. It is a full binary tree, but perfect binary tree means all non-leaf nodes have 2 children and they are at same depth. So, consider this example. So, this is a binary tree, but it is not a perfect binary tree. So, how we make this as a perfect binary tree? Now, all non-leaf nodes have 2 children. In this example, so this is the non-leaf nodes. So, all the non-leaf nodes have 2 children, here 2 children. So, for this node 2 children, for this node 2 children, and if you observe that, so all are at same depth. Okay. So, this is perfect binary tree. So, next one, so complete binary tree. A complete binary tree is a binary tree in which all levels are completely filled except possibly for the last level, so which is filled from left to right. Now, consider this. Now, is it binary tree or not? Yes, it is a binary tree, but it is not a complete binary tree. Why? The property of complete binary tree is all levels are completely filled except possibly for the last level. So, this is the last level. Now, here all levels are filled, but here we are not filling the new node from not left side. Now, that is the property of complete binary tree. Now, these nodes we will from left to right. If we insert this node here, then it is complete binary tree. Okay. So, next one is balanced binary tree. A balanced binary tree is a binary tree in which the height of the left and right subtrees of any node differ by no more than 1. So, consider here. So, this is the binary tree, but it is not a balanced binary tree. Why? The height of the left subtree is 2. So, height of the right subtree is 0. So, 2 minus 0, 2. Always it is balanced means it is not differ by 1. So, if we insert a node here, then it is balanced binary tree. Okay. Degenerate binary tree. A degenerate tree is a tree where each parent node has only one associated child node. So, one associated child means, so this is the root, it is associated with only one child. Now, this will associated with only one child. Now, this will associated with only one child. Now, this will associated with only one child. Now, if you observe, it seems like a linked list. Okay. So, this is the starting node. So, this is the ending node. Okay. It essentially a linked list in tree form. It offers no advantage of tree data structures over a linked list. Why we need binary tree? To access the data easily. If you are maintaining the data linearly like this, then there is no use of tree data structure. So, summary of the session. In this session, we learn what is binary tree. So, binary tree are the data structures in which each node has at most 2 children, so called the left and right children. And we see how to find maximum number of nodes possible in a binary tree, that is n equals to 2 power h plus 1 minus 1. And we discussed about how to find minimum node number in a binary tree, that is h plus 1. And we discussed how to find minimum height h equals to log 2 n plus 1 minus 1. And after that we discussed about so different trees, so full binary tree, perfect binary tree, complete binary tree, balanced binary tree and degenerate tree. So, full binary tree means it have the children either 0 or 2. So, one children not allowed in full binary tree. Okay. So, perfect binary tree means all non-leaf nodes have 2 children and they are at same depth. A complete binary tree means possibly we fill all the levels except the last level and the new nodes are filled from left to right, that is complete binary tree. So, balanced binary tree means the height of left subtree and right subtree does not differ not more than 1. And degenerate tree is a tree where each parent node have only one associated child node. Okay. I hope you all are understand. So, what is binary tree and different types of binary trees we have in data structures. So, next class we see tree traversing methods. Thank you.